Okay, so today we're kind of combining exponential logarithms, kind of wrapping up the whole chapter. This certainly does actually look like an easy problem. So, um, especially a lot of our problems actually so far in this chapter have kind of worked out nicely. Like eventually they kind of had the same base. Like these have the same base, so x equals 2 is kind of an easy problem to solve. Um, because when problems have the same base, again, we got a few fractions, but it was mostly stuff we didn't even need a calculator for. Today, we're going to do some problems that aren't quite so pretty. You might have to use a calculator or solve, at least have a, I'll show you the difference between if it's on a no calculator test or not. But the reason it's going to be tougher is because the base is not the same, right? So if the base was the same, it would be, maybe a piece of cake. This one's going to be a little tougher, just as far as the numbers can be messier. So method number one, I'm going to call a pretty creative name. It's called change the form. So you can see, hopefully you can see that this problem is in exponential form. So I need you to put it into log form. So let's do that. So to solve it, that's how we solve in this chapter. If you don't know that, that's something you need to know. So log 2 of, let's see, the exponent goes in the other side of the log. So x goes over here, 5 goes here. So that's actually the exact answer. If this was a no calculator test, what is x? X is log 2 of 5. If this is a calculator test, portion of the test, then you would hit log. That's control 10 to the x. Oops. So control 10 to the x, base 2 of 5. And if you want a decimal, I usually hit control enter. It's one way to get it. So we got decimal. So that's equal to 2. So x is approximately equal to, I should say, 2.32193. Got at least 3 decimal places, probably fine. That's the way, honestly, most students are going to use it. It's probably the easiest to change the form. I'm going to show you another method. It's kind of elegant. It's takes a little longer to do, but let's try it. So what you do is it's based on this idea that you can. I'm going to call it this way: take the log of both sides. So it's this idea that we can actually just take the log of both sides of the problem. So you look at these two sides, 2 to the x and 5. So I'm going to take, and because it's base 2 there, this is a base 2 under the exponent. So I'm going to take log base 2. So log base 2 of 2 to the x equals, take the log of the other side as well, log base 2 of 5. If you remember the properties, I think one of the properties we learned was about, or the laws of logarithms, is about that exponent. We can actually put it out front, right? So x times log base 2 of 2 equals log base 2 of 5. And hopefully you know log base 2 of 2, 2 to the what power is 2? That's just 1. So we have x times 1 equals log base 2 of 5. And so x equals, we get to the same answer they did doing the other method. But it was just so beautiful. It's such a nice method there. But honestly, no students really use this method. But it's really neat. It shows you just the beauty of mathematics. It just takes, 4 or 5 steps to do what we did in 1 step over there. Okay, let's try this one and see how it works. So we're just going to try a couple problems. I think you get this. So this is equations. So we're going to try to solve them. And probably the easiest way is just to change the form, right? So this will be log base 2 of 5 equals the exponent, because logs equal exponents, x plus 2. One more step, we've got to subtract 2 from both sides, and you get x equals log base 2 of 5 minus 2. If it's no calculator test, that is the exact answer. That's what I want. If it's a calculator test, you would then get your calculator out. Here, I'm just going to copy that and then just put minus 2 after it, I think. And the answer is, oh, sometimes you forget to hit control equals. Okay, so this is approximately to 0.3219-ish. Okay, so those are the exact answer and the approximate answer. Now we have this one. I really like this problem. I want to change the form, but I don't know if you noticed, I can't change the form. That's not exponential form. That 4 is in the way. So I've got to get 4 on the other side. You know, of e to the 2x equals, I'm going to write this as 5 over 2 because that fraction simplifies. And we're going to put this in a log form, right? So that this is now, because this is actually like exponential form. This is a number to a power equals a number, even though that number is a fraction. So log form would be natural log because the base is understood to be e of some number equals the exponent, which is 2x. And so 5 halves would go here. We learned the other day that can be natural log of 5 minus natural log of 2, by the way. Last step, divide by 2. So you divide that whole side by 2. And so you get the answer there, which is x equals, again, this one big fraction, natural log of 5 halves divided by 2. And then you can type that in your calculator if you want to get the approximate answer. How do you solve a log equation? Let's see. Let's call that change the form. That's why I called it that, because if it starts as a log, I just want you to switch it and put it in exponential form. It helps you to understand there's an e down there, because this is going to be e to the first equals x plus 2. Last step, subtract 2. You get x equals e minus 2. That's the exact answer. If you want to type that in your calculator, you can get the approximate answer there. So you got to be careful. So like this equation, you, let me go back for a second. Okay. So this equation, you can't just change the form. You've got to use your laws of logarithms. You've got to push those guys together, and then we might be able to change the form here. So let's try this. So we're going to go log, which is base 10, right? And we're going to multiply x plus 2 times x minus 1. That's inside of the logarithm now. I made that one logarithm because now I can change the form. Understand the base is understood to be 10 when it's just log. So change the form. This would be 10 to the first equals, I'm going to go ahead and multiply this out so we have it. I'm going to FOIL that, x squared plus x minus 2. Now this is a quadratic, so it equals 0. So I'm going to subtract 10 from both sides. And we're going to try to factor and solve this thing. So 0 equals x squared plus x minus 12. Sorry, plus x minus 12. Let's try to factor it. I think it does actually factor. Let's see, x and x. I'm thinking 3 and 4 plus and minus. So I get x equals 3, x equals negative 4. And so now here's what you have to do. Anytime you solve a log equation, because you can't take the log of a negative number, you got to just check. Like when I saw this negative 4, I thought to myself, I wonder if this is going to work. If you plug in negative 4 here, negative 4 plus 2 is negative. Log of negative 2, you can't take the log of negative. That's what's called an extraneous solution. Let's try 3. 3 plus 2 is 5. That works. 3 minus 1 is 2. That works. That looks like a real solution. That one's extraneous. So especially when you get a negative answer, but even every once in a while, a negative answer will work if you have, if this is a big enough number inside of there, as long as you plug it back to the original problem and make sure that it forms a positive number. Let's try this one. So this is in log form, so we put it in exponential form. 2 to the third equals 25 minus x. We're going to solve that. Subtract 25. So 8 minus 25 is negative 17. Divide by negative 1, you get x equals 17. If you plug that in, 25 minus 17 is 8. That's positive. I think that's going to be an answer. As long as we didn't make a mistake, you can always check it. Log base 2 of 8 is equal to 3, so that works. This one, wow, there's a lot happening here. So this was kind of a different. I want to show you a problem like this. Maybe you see a few of the exponent rules. Maybe you see on the right-hand side, we can probably push those logs together. Maybe you see on the left-hand side, you have an exponent that we can definitely move. So let's do that. So we get log of x squared equals, let's push this one together. So this will be log of 2 times 3x minus 4. I'm going to go ahead and just multiply it. So that'd be 6x minus 8. Okay, this is not really like an official property. It's not listed anyway. But basically we're saying this. Log of something equals log of something. What must be true about those two things? Just logically, right? Log of something is log of something. The logs are inconsequential at this point. I know that x squared must equal 6x minus 8. Right? Those things must be equal because they're set up that way. Let's subtract 6x, add 8, so we get x squared minus 6x plus 8 equals 0. I'm hoping this factors. If not, I'll use quadratic formula. So let's factor it, and we get x and x. Let's see, probably 4 and 2. Maybe, I guess both of them are negative, so x equals 4 and x equals 2. Let's just double check those. Plug it in. They both work for x. 4 and 2 are both positive. 12 minus 8, if I plug in the 4, that 12 minus 4 is 8. If I plug in 2, that'd be 6 minus 4 is 2. Those both work. They're both positive, so 4 and 2 seem to be both answers there. And you got it. That's the lesson.